Forever. Okay. All right. Then I'm gonna go ahead and get started. You can start the timer now. All right. Hi. My name is Darren Gibson. It's right after lunch. I know you're all tired. I definitely am. So I'm gonna make this quick. I work for ZealCon. I'm a professional functional programmer. I'm a Scala fanatic. I'm the organizer for Tulsa Lambda Lunch. I never stop talking about functional programming. No, really, ask my coworkers. Seriously, there have been complaints. That was their awkward laughter now. My talk today is what the function, some small steps you can take towards reasonable code. Or alternatively, things obvious in hindsight that my professors kept telling me in college and I didn't listen to. And a couple of things that they didn't say and I wish they would have. So I bet you're wondering, what do I mean when I say reasonable code? So here's the dictionary definition. I could read that, but that's not really what I mean. I could mean equational reasoning or math, which a lot of functional programming people will talk about when they mean reasonable. But what I mean, what reasonable code means to me is code you can understand the intent of at a glance. Code you can easily test, code you can easily compose together, and code you can easily predict how it interacts with other code. So tip number 1, short functions. You should be able to read the entire function without scrolling. How can you understand a function at a glance if you can't read it in a glance? If it's too long, it also probably does too much. You should make the functions smaller, split them up, and compose them. Tip number 2, know your design patterns. So knowing common design patterns helps you recognize what someone was trying to do with a piece of code. That someone might be you years, months, hours later. So common O design patterns, factory, builder, singleton, etc. Everybody knows gang of 4 probably if you've been programming for a while. And then FP design patterns are like functions, tagless final, finally tagless, aka the F it all pattern as my coworkers call it. The free monad, functions, some category theory, or functions. That's the design pattern in FP. All right, so tip number 3, beware of not invented here syndrome. Or to Polkat's law of mistaken invention. Anything that I invent that is sufficiently polymorphic and plausibly useful probably already exists in Scala Z. That's big fancy words that means look for libraries that already do what you want to do. If you think the thing you made is super cool, somebody probably already made it. This is just reality, right? If not, you should go write that thing and open source it so we can all use it, because if it's super cool, I want to use it. Or at least make a library for you internally so you can reuse it and your coworkers can reuse it. Tip number 4, write exhaustive unit tests. If each functional unit is well tested, you can compose them with confidence. Automated acceptance test, BDD, is hugely useful, Gherkin Cucumber, etc. The English descriptions help you communicate with your users and future maintainers. Tip number 5, good naming. My coworker Eric will say I'm not always the best with this. I use short variable names all the time, but really, you should do it. It's not always easy. All right, now the actual functional tips. So tip number 6, use pure functions whenever possible. They're easier to test, they're easier to understand and reason about, and I'll explain that in a second. So what makes a function pure? Equational reasoning, that mathy thing we talked about earlier. Basically, you can replace a function with its return value. So given inputs always give you the same outputs. This makes it really easy to test because you can just replace the function. So the inputs return nothing more. See tip number 7 and 8. So tip number 7, don't mutate your state. Tools like Redux help. You can use tools like Ramda or Lodash or Lodash FP to do immutable transformations on lists. These kind of things make it easier to reason about because you're not changing what was already there. You're making something new to pass along. So what do I mean by state though? I mean local variables, function parameters, your inputs are your functions. Definitely never reassign those if you take nothing else from this. Class variables, variables in general. That's what I mean by your state. So tip number 8, limit your side effects or your effects. Effects make it really hard to understand when things happen if they're just buried in your code somewhere. Tools like Redux really help here. But what do I mean by effects? I mean mutating state. I mean reading and writing from console, from the database or the network, or just reading and writing from anything. But without so-called effects, my code doesn't do anything, you might be thinking. But that's why I said limit and not exterminate. You want to move those effects to the edges of your program, test them carefully, make sure you test all of the edge cases, and never trust your user's input. Tip number 9, embrace static types. Now, this is not purely FP. Many languages have static typing, and there's lots of debate. Lots of people will throw tomatoes at me for saying about static types because they're dynamic people. Tools like Flow and TypeScript, PureScript or Elm are useful for static types. But static types ultimately boil down to a form of documentation. They tell your future developers what the inputs and outputs of the function are in a glance, something that maybe in JavaScript you wouldn't be able to easily tell. I have the names, but you don't know if it was supposed to be a number or a string maybe. So this is a documentation that flows through part of your code and is often part of the language. Static types can also be a type of test. So they're a first line of defense unit test. When you're writing your static types, your compiler will tell you when you screwed something up, and I screw up all the time. They also help make refactoring easier because if you break something in one part of the code, make a change, you know immediately that something in another part of your code isn't going to work. But tools like Flow for JavaScript make it where it doesn't get you in the way. All right, so here's a quick example of what I mean by types. We got the function sort and the function sort with. These are both from Ram.js. See, one takes a comparator, one takes functions. At first glance, I didn't know what this actually, what's the difference. But when you add the types, you can tell that the second one, the sort with, takes an array of functions rather than just a single function. Now I know a lot more about what's going on than maybe I knew before. So tip number 10, use higher order functions like filter, map, flat map, reduce or fold. Why? Lee Howey's principle of least power, or check out Lee Howey's blog for more information on this. But use the least powerful abstraction to solve your problem. And by power, I mean useful. By least powerful, I mean most specific and least general. And by that, by using this, it's more understandable at a glance. Here's a quick example of a while loop. Who can tell me in 30 seconds what that does? Sorry, you don't have 30 seconds. But this is the equivalent written using Ramda, where you can see I'm doing a filter, I'm dropping a thing, and then I'm parsing it, and then multiplying it by 2, and the intent is relatively clear. So that is the end of my talk. ZealCon is hiring. Go to zealcon.com/careers, shameless plug here. My team at ZealCon is hiring, so if you want to do functional programming with me, go here, look at our stuff. Learn more about FP at Tulsa Lambda Lunch at 36 Degrees North every last Tuesday from 11:30 to 12:30. Also, OKC FP, they're awesome. Here's my socials. Thank you, everyone.
You can stay plugged in if you want.
Okay.
But you've already, it's whatever works. We've got 2 minutes for questions. Anybody got one?
Yes.
Real quick, yes or no? Elm in production, yes or no?
I don't use Elm personally,
No.
but Elm is in production in many places, yes.
What roles are you hiring for?
We're hiring for a senior software engineering position where we'll do Scala on the back end and JavaScript on the front end. We use React and Redux for front end development. Any other questions? All right. Thank you. Do you have one? Yeah, please.
So if you have a team of, say, 10 people, and you're the only one on the team that is strongly in favor of functional programming, and everyone else is against it because it's easy to mutate stuff, what's a one-sentence thing I can use to argue against state mutation?
It's a very good question. So he asks, what's a one-sentence explanation you can give for why you would want to avoid state mutation for a team of people who are maybe less functional inclined? And I can't do that in a single sentence. There's a lot of reasons. Simple made easy, sure.
Because our problem is complexity, and that will reduce. It's a long sentence.
Yes.
Every time you restart the app to fix it or reboot your machines to get it working, you are resetting global immutable state.
And if you're doing parallel development, have you ever heard of a race condition? when you're mutating the same state in two different places, that's a lot less of a problem when you're using a mutable state. Any other questions? All right, I believe that's my 2-minute time. Thank you again, everyone.
Thank you, Darren. Appreciate it.